Hello and welcome to this video that continues with GCSE Mathematics for the numbers section. So in this class we will look at prime numbers and prime factorisation. So first of all we need to consider, well, what is a prime number? And a prime number is a number that only has two factors. So it has the factor of 1 and itself. So obviously when we were doing factors before, say we had a factor, when we were looking at 2, and we want to find what factors make up 2. If you do 2 divided by 1, you get 2. So you will have a factor of 1 and 2 that are factors of 2. And notice that that's 1 and that's itself. Well, for prime numbers, these are the only factors that it has. And another example for a prime number is 3. So 3 only has factors that are itself, or 1. So if we do 3 divided by 1, we get 3. So if you remember from the factors class, we say, well, 1 is a factor and 3 is a factor. If we did 3 divided by 2, that would equal 1.5, therefore 2 cannot be a factor. And then if we do 3 divided by 3, we get 1. So we get 1 and 3, but remember, we have already seen this because we did this for when we did 3 divided by 1. So therefore, this is just to repeat. And there we go. But every other number, if you divided 3 by it, or 3 by any other number, would give you a number less than 1. So therefore, we finished. And we can say, well, the only factors of 3 are 1 and 3, therefore it must be a prime number. So the first few prime numbers that we give are 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on, so on, so on. They go on to infinity. Essentially, they can continue going on. There will be numbers continuously getting bigger and bigger and bigger. But for GCSE, you only really need to know for the first few prime numbers in most cases. The last thing to check is obviously be careful with 1, because 1 is not a prime number. So don't think of it as a prime number at all. It is not a prime number. The first prime number is 2. So the next thing in today's class would be prime factorisation. And prime factorisation essentially is how you can find prime numbers that make up a number. So all numbers can be found out by only multiplying prime numbers, and each number has a unique prime number factorisation. So they all have a unique combination of prime numbers that multiply together. To do this, the method that we use is something called the factor tree method. Now, the factor tree method is something where you get your starting number and you split it up into factors. So if we take, for example, 12, what we can use is we have 12 and we look at the factors of 12. So we've got 12 and 1, which is a bit useless because we get 12 again. We get 4 and 3, and we get 6 and 2. So in this example, they've done 6 and 2. So we will follow it through. So 2 is a prime number. So what we do is we highlight it, as we've done here, and we keep it. We remember it, we highlight it so we can come back to it later on. Then we look at 6. Well, 6 is not a prime number. 6 has the following factors: 6 and 1, and 3 and 2. Well, 6 and 1 is not useful because we still got 6 again, so we're going to have to deal with it again. So we use 3 and 2. And 3 and 2 are both prime numbers. So we highlight them, and we no longer have any number that's at the end of our branches that are not prime numbers. So every number here is a prime number, and therefore we found our result. So what we can say is that, well, 2 times 2 times 3 will give you 12. And therefore the prime factorisation of 12 is 2 squared, because 2 times 2 is 2 squared, times 3. Essentially, remember, we haven't done powers a little bit later on, but you may have done it before. So remember that if you've got 2 lots of 2, so if you multiplied 2 2's together, we call that 2 squared. So 2 squared times 3 is equal to 12. So these are the prime factorisation of 12. Let's have a look at another one of 12, but this time we did 6 and 2, but let's show that 4 and 3 will give you the same result. So if we've got 12, and we choose 4 and 3. Well, first of all, we've got 3, which is a prime number, so we highlight it and then leave it alone. And then we look at 4. Well, 4 can be made up from 2 and 2, or 4 and 1, but 4 and 1 again is not helpful to us, so we use 2 and 2, and notice that we are finished because they're both prime numbers. And look, again, we've got a 3 and a 3 here, a 2 and a 2 and a 2 and a 2. So we've got exactly the same prime factors that we got using 6 and 2 and 4 and 3. So it doesn't matter which one you use at the start. Let's have a look at another example then. So another example is 72. So when you have a bigger number, sometimes it's hard to know where to start. I generally divide everything by 2 first. If it doesn't divide by 2, then try 3, try 4, try 5, 6, 7 until you get the lowest number, because it just helps you know where to start from rather than just guessing random numbers. So I start from 72 and divide it by 2. Notice here that I've divided by 2. This is a prime number, so I've highlighted it and I've left it alone. I then come to 30, so 72 divided by 2 is 36, and 36 has numerous options. You've got 6 and 6, you've got 4 and 9, and you've got 2 and 18. In this case here, I've chosen 6 and 6, but you could have used any of these options. They are both fine. So I picked 6 and 6, and again, I look at the factors of 6. Well, the only factor that it has that we can use are 3 and 2. So we use 3 and 2 for both of these, and we notice that we can finish at this point because all the ends of our branches are prime numbers. So we end up with the following: 3, 2, 3, 2, 2. So it's 3 times 2 times 3 times 2 times 2. We've got 2 lots of 3, so we say that's 3 squared, and we've got 3 lots of 2, so we say that's 2 cubed. So the answer is going to be 3 squared times 2 cubed. Here is some examples of some prime factorisation. If you want to pause the video and give these a go, that would be a good test of whether you know it or not. Otherwise, we will go through it in a second. Okay, so hopefully you paused the video and gave these a go. Let's try number 1 then. So number 1 is 75. So we've got 75 and we want to split it up. Well, 75 I know is 25 times 3. So I'm going to pick 25 as my first 2 pairs of 25 times and 3 as my pair of factors. And then what I can do is I will highlight 3 because that's a prime number. And then I will look at my next result. So I've got 25, and I know that 5 times 5 makes 25. So I'll take 5 and 5. And I know that these are prime numbers, so I will highlight them, and I don't have any more numbers that are not prime numbers, so therefore I can finish. So I can say, well, 3 times 5 times 5 is equal to 75, which is the same as saying 5 squared, because I've got 2 lots of 5 multiplied together, times 3. So that is 75 as a product of its prime factors. Notice as well the language that I've used. We're expressing, so you want to write 75 in a different form, as a product, which is the result of a multiplication of its prime factors, means that we're going to write the product in terms of prime numbers only. So sometimes the language in the question can be confusing, but we're using more difficult language here so that when you see it in the exam, you will not get, you will know exactly what the question means. The next one is 99, so we'll do 99 as a product of its prime factors. Well, the one that I will pick is going to be 9 and 11, because that is the one that shouts out to me the most. I note that 11 is a prime number, and then I go through and I say, well, what makes up 9? Well, 3 times 3 make up 9, and they are both prime numbers, so I say that finally my answer to this one is going to be 3 times 3 times 11, which is equal to 3 squared times 11, which equals 99, which is our result. The next one that we have is 150. So 150 is a product of its prime factors, and this one is a bigger number. Now we're going into 3 digits. When we get to 3 digits, if we've got a 0 here, I always try and use divide by 10 because it helps us reduce the number very quickly. So divide this by 10, we get 15 and 10. And then let's have a look at 15. Well, I know 15, if 5 times 3 makes up 15, so we can put a 5 and a 3. And then for 10, that is a 5 and a 2. And I note that all of these results are all prime numbers, so therefore I finished my tree. So I can recite the result as 5 times 3 times 5 times 2, which is the same as 5 squared, because I've got 2 lots of 5, times 3 times 2. That's my result. The next one is 560. 560 as a product of its prime factors. So 560, if we go to break it down, we've got 56 and 10, because we can divide by 10. We know from the previous one that 10 can be made up of 5 and 2, but how can we make up 56? Well, you can use, in this case I've used 8 times 7, so 8 times 7 is 56, and then 8 is a prime number, so let's highlight the prime numbers that we have so far. But 8 is not a prime number, so we need to split this up further. And I know this is made up of 4 and 2, where 2 is a prime number, and then 2 can be made up, 4, sorry, can be made up from 2 and 2. And there we go, that is our final answer for 560. So this one's a bit of a bigger tree. They're not always nice and easy, but generally these will be with more marks. And then to finally write it up, we say, well, it's 2 times 2 times 2 times 7 times 5 times 2, which is equal to, well, we've got 1, 2, 3, 4 lots of 2, so that's 2 to the power of 4 times 5 times 7 is our result. And the last one is a big one. It's 1010, so 1010. So what we can say for this one is, let's split it up. So let's do, this time I will divide by 5 instead. So I get 5 and 202. You could have picked a number, you could have divided by 10 as well. It would just try something a bit different. And then to split 202 up, well, I don't really know many factors into 202, but I noticed that there's a 2 here, so I know 2 will go into it. So 2 and 101. Now this one is a bit difficult because you have to go through a lot of numbers to find that 101 is a prime number. So generally what you can do is you can do 101 and divide it by 2 and find out that it must be an odd number. Then you can do 101 divided by 3. That might give a result, that might not give a result, but if it doesn't give a result, you know that any 3 times table will never give that result as well. It's the same for 2, 101 divided by 2. So therefore, I know 101 divided by 4 will never work, but 101 divided by 5 might work. But obviously I know there's a 1 here, so it won't work. But it's just a little bit of a shortcut. You could divide by 7, would be the next one that might work, divided by 11, and essentially divide the numbers by prime numbers till you get up to the value of 101. But 101 is a prime number, so therefore we have finished. So our result for this one is simply 2, 101 and 5. So our result for this one is going to be 101 times 5 times 2. This one is quite a hard one, I think, and would be worth a couple of marks in the exam, as it's not so obvious that 101 is a prime number. And that's it for this class. If you have any questions, please let me know. Otherwise, thank you for listening.